going to show you how people do lie, but it's going to be a very, it's the beginning of a project. So according to the definition of what this talks will be about, it can be from any stage of project, advanced or something that of a beginning. So this is going to be a beginning of an exciting project, learning to lie. And it's my work, and I'm a PhD student here in the University of Michigan in Ross School of Business in the marketing department. And I'm working with Fred Feinberg, who is a professor in the department, and Elizabeth Brooke from ISR, from sociology, and also from with Dan Ariely. He's in Duke, and he's a behavioral economics professor. So this project is based on my observation of a very interesting data set. Some of you may have heard that there is an affair-seeking website. There are actually some of them. Affair-seeking online dating websites. The people that want to have an extramarital affair are logging in and are joining the website to find an affair. Now, it might be quite surprising, but there are such websites, and I was pretty shocked to find out about it when I just came here as a student, and I was pregnant, and I was very naive, and then I heard about it. Now, thankfully, I heard about it just because we were fortunate to have a huge amount of data that were given to us to work with. So it's all with the collaboration of the website. And we received generously approximately 1 million profiles and activities of all the active users on the website. By activities, I mean chats, messages, searches on the website, and also profile and profile changes. Now, just technically, are we accepting questions during or after? Okay, so I can accept questions whenever you have. Please ask. And can you tell me like 2 minutes before? Sounds good. So we have approximately 18 months of observations, and I chose to look at those that I can see their full lifetime on the website from the day they join until the end of my observations. So this is approximately this 1 million users. And some fun and quick facts, because I know it's a pretty sexy, literally, data set. So some people are pretty interested to see who are these people that are actually logging in to find an affair. I'm moving here so that the camera can catch me. So not all users are surprisingly consider themselves as attached, whatever that may be. Actually, almost a third of them are declaring themselves to be single. 67% of them are women, and 33% of them are men. And it is a we have a selection bias here because we got from the company only those that have paid, that are active members, and men needed to pay and women did not. So we have some kind of selection there, but we can overcome this if we do some tools. What we also know that some of these people are looking for a long-term affair. Some of them are looking for an online affair. So this kind of differs. Some offline, some online, some long-term, some short-term online affair. The average age is approximately 40, but surprisingly, as you can see here in the plot, surprisingly many people are either 37 or 45. You can see these jumps here, which kind of make me suspicious about their honesty on the website. And that kind of raises the question of, are they actually honest? Now, I don't know who of you are on an online dating website, but usually the legitimate website will kind of control for changes as such, but there can still be deceptions, and research have shown that there can be multiple reasons for why people would lie on such websites. So we have decided to get into that. Since we observe what they're looking for, we can actually try to understand and reveal the reasons for their deception or lying on the website. The honest truth is that we don't know what the honest profile is. Some people lie, or some people are becoming more honest. Yes?
I think it's a website for affairs. They might not be honest.
That is correct. That is correct, yes. So we're not trying to learn about the honesty. We don't try to kind of learn because we don't know what the truth is. However, we do have a survey that was run on random sample of the population of the users on the website in order to verify some of the findings that we see here. So they are generally surprisingly honest, but they do change their profile throughout time. And this is where we're heading to. So approximately 112,000 people change their profile items at least once. Now, what do I mean by profile items? There is this initial profile that is pretty hard to see here, but that includes their date of birth, their limits, what they're looking for, online or offline affair, etc., height, weight, body type, ethnicity, and greeting, which must be included and is a greeting, textual analysis. and location, which can also change. So some of this can technically change. You can reduce your weight, you can change your body type if you're going to the gym now, but some of these things like date of birth cannot change. Ethnicity usually cannot change, and height after the age of 18, which is the limit, the minimum limit, cannot usually change. So 43,000 users changed one of these 3 items that are immutable: ethnicity, date of birth, or height, and this is something that is of interest to us. But all of these types of changes are actually kind of interesting. But why did they change? So there can be multiple reasons, and we are trying to reveal those. If we're trying to, at least, so this is, I said, it's an initial part of this project, so we try to analyze it based on whether they're single or attached, whatever they define it as attached, and we see that there is some differences here. So this is conditional on changing one of these 3 items. How do they kind of change different type of item or the other? So 52% of the users that are single and that have changed their profile item have changed their date of birth, comparing to those that are attached. I don't know why this is the case, but we can perhaps shed light on that. More of those that have changed, that are single, change their height than those that are attached. With women, we don't see much of a difference. So you see here that it's almost the same. I don't know why yet, and it might not ever be revealed, but this is some descriptive that we have initially started. So if you have any suggestions, I'll be happy to hear. Other things that we've looked into are the differentiation between cyber affair and long-term affair. There are 4 more definitions of what they're looking for, but it's kind of ambiguous in the definition. So just to illustrate the differences, I put these 2. Cyber affair is something that you probably will never meet this other person. So people there are sometimes changing their height because no one will ever see them, and they change their height more than those that are seeking for something that is a long-term affair, where they might actually meet that person and will be revealed to be 2 feet less. Okay, any questions so far? Okay, you're all shocked to hear that people lie, right? I'll stand here. Okay, and I'll talk with this one. Okay. So I wanted to see if there are actually differences in the value of changes that people have. So this is the percent change, conditional on changing any date of birth. So conditional percent change in date of birth. Now there is no percent change in date of birth, so it's at least the age divided by the average age of that population that have changed. And you see that people that are looking for a cyber affair have actually have bigger magnitude of changes. So I'm dividing it to positive changes and negative changes, and it seems to be that they're more extreme in their changes. This is just the average, so there should be more analysis here, but for this short presentation, this is what can be digestible, I guess. And similarly, we can see that the percent change in height is also more extreme, at least in some of the membership age, and I'll explain what that is in a second, for those that are seeking an online affair versus those that are looking for something long-term. So membership age is something that is important to understand because people are more active initially, and some of them survive on the website longer and some are not, and this can also be a reason for them. And one of the questions that we want to see, and this is why optimizing is part of the title of this talk, is that we want to see if people are optimizing, their profile based on their experience on the website. If they learn that one profile is more attractive than another profile that they want to have for themselves, they might actually change the website, try to optimize themselves as the product in order to attract more searches and more messages on the website. And this is where we're heading to. Now, just out of curiosity, I checked to see if people are differing in their gender, to see if because research suggests that men want to be taller and that women want to be younger, but I didn't find, at least in the raw data, didn't find any such differences meanwhile. Okay, so this is the change in date of birth and change in height, and no such, and also change in weight here, and no such, not so much of it. It's definitely not significant differences, but not so big as well. So these are the next steps. Measure this of success to profile changes. If they change this profile in one way or the other, are they actually succeeding in getting more attraction or getting more successful correspondences? And do they actually do it intentionally? Do they optimize? Do they try? Do they learn how to optimize their profile? And perhaps shedding light on other possible reasons for profile changes, given this specific setting. Do people change their profile based on their type of affair? Do they disguise themselves? Do they have kind of wishful thinking? Perhaps they want to reduce weight and they are hoping to be lighter by the time they meet this attractive person. Does this actually, do they change their behavior based on their disguise? So if they're getting younger, are they actually talking younger or whatever? That is going to be more challenging task, but perhaps we can go there as well. So if you have any comments, any questions, I'll be happy to hear now. I don't know if we have time, but also after. Okay, and this is my email and my Twitter handle if you want to communicate later. Can I get questions? Okay, yes.
One thing that's been kind of talked about a lot for social networks is bots and other fake users on it. Is that something you're looking to try to identify before you're trying to, or is that something you're interested in examining to determine if there are fake profiles that you can analyze?
That's a great question. So actually the data that we got is from the company, and we know that these are active users. They have not given us the bots as far as we know. And the data, as far as I looked into, are okay. Now, it might be the case that some of the users have not really intended to have an affair and have logged into the website and even joined and even paid to do something else. But this is not something that I'm going to analyze. However, you're correct that some of the reasons that the social sciences show, and one of the main researchers is sitting right here in the School of Information, Nicole Ellison, and she's showing that some people are kind of scared that some people will be bots, or maybe not bots, but some people that are not intending to do good, and therefore they're disguising themselves to protect themselves. So that is a great point. Yes?
It's likely a sensitive data set. What is the motivation of the company to share the data with?
So they actually wanted to. So the question was, what is the motivation of the company to share this data? So the researchers that I'm working on are pretty highly known, and they wanted to be collaborating with these people, especially Dan Ariely and Elizabeth Brooke, and Fred Feinberg, my advisor. I just jumped in as a PhD student, yay. But they wanted to learn about the affair seeker's nature and to learn about this kind of phenomena, what is going on their website. So they wanted to take advantage of the tools that marketing research and social science research can give to learn more about their own customers. Yes?
Did you get the data with all PII in it, or did you get anonymized data with
It's all anonymized data. We don't have any emails, any nicknames, any names that have ever been used. So they removed it. They worked hard to give us a very, very highly anonymized data. Yes, so I think that was...
Yeah, that's it. Thank Dan. Presenting our next speaker, this is Jule Kruger, and she's going to be telling you about something that's even darker than the dark web, which is scraping U of M public salary information. So.
Yeah, hi. So thank you for the introduction. I'm excited to be here. My name is Jule Kruger, and I'm working on a project where I'm scraping an online database of salary data. And just to give you an idea of how that came to be, on the one hand, I'm a political scientist by training, and I've been using R since 2009. And this year I started teaching myself Python because I was really interested in using it to scrape data and get more data from the web. And then I was looking for a project where I could kind of apply my skills and keep practicing. And in the process of that, I came across the UM salary database, and searching it, I felt like that would actually be quite interesting to explore, because there's a lot of research on why there's a pay gap between men and women, based on, for example, that women are not socialized to ask for raises or not negotiate their first salary. And so I was interested if actually at the University of Michigan there was such a pay gap if we look at the data. And I don't know how many of you are familiar with this website. All right, and how many of you work at the university? I work at the university too. I have to disclaim though that this is not a project that I'm doing as part of the university. I'm doing this in my free time. And I've actually, since I started this project, heard also that there have been initiatives for diversity and equity where the base had suggested to have these comparisons made. And sometimes the leaders of these initiatives were not very interested in pursuing these goals further. So I still don't know if I'm ever going to get into trouble for working on this project and presenting on it. So I was interested in scraping this database, and as you can see, you can search it, and you always have like a list of the recent searches. So it's never occurred to me that someone was looking up my salary, but I was also looking up here. So, and I just started scraping it by department. And the good thing is, when you scrape by department, you can also go by years. So I can get data also over time. And so what I did is I was using the Selenium package in Python to scrape this database. And then once I had scraped all the departments and the information for every person who works there and every year, I took out all the first names and middle names and sent those to an API that's called genderize.io. And I tried to get information on whether this person is actually male or female. And once I had that data, I started using R to plot it. So I was using ggplot and the ggridges package to start visualizing this data. So my goal for today was to come up with some plots for you guys so I can show you like the distributions of the incomes by men and women across the university. And so to this date, I have 1,950 departments scraped, and I still have some issues. I don't have all the departments in all the years because unfortunately the human resources office has no like name conventions, so they sometimes change. So sometimes I have departments where a few years are missing because I automated everything, so I'll have to go back and kind of like correct. And also from the index of this database, which is actually not run by the university, it's a private individual who's putting this online for the public. They also don't have a complete index, so I already realized there are some departments missing, so I couldn't get those at the first run. Then I pulled out about 1,800 unique names, first names and middle names, but when I sent those to the API, I was only able to identify about 2/3. So I still have about 3,755 individuals, which I can't tell if they're male or female. It's just because the university has really people working from all over the world, coming from many different countries, and even though the API really covers a lot of countries, they just don't have all the names. So if you want to help me figure out the remaining ones, talk to me afterwards, and I'll send you some CSV files for you to code by hand. And I also want to say that in general, this has been a really exciting project because as I talk to people, people get interested. Lots of women are really encouraging and ask me to send them some plots very soon. And also I've gotten some really great support from friends. I don't want to name anyone because in the end, I want to be the only one who gets into trouble for this. But if you've helped me and you know who you are, then thank you so much. So I just want to let you know that all these results are very preliminary because I still have a lot of missing data. I have years that are missing. I have departments that are missing. So whatever plots I show you, don't take me up on it. Don't quote me on it. So are you ready to see some? Perfect. So let's look at type of jobs. So if you look at the school, of course, like the president's always like one of the highest people. But then if you have the deans, you have the distributions by here. You can always see like the blue curve is the males and the red curve is the females, and then we can see it over the years. And so what you can see here is actually that there's a pretty good spread, right? So men and women are kind of like covering the entire range, and it actually seems like it's more converging towards equality in 2017. So I find that very encouraging because you also see at the university that these initiatives are kind of like moving towards equity, and so I think that's actually quite a good part. Like it's starting to flatten out, right? Like for the last fiscal year, yeah.
This is by year. This isn't by job, right? That's why you're seeing a lot of local institutions.
Yeah, this is by year. Yes, yeah, you're seeing, this is every year, all the individuals who are working, and it's not a lot of deans at the school either. So, I mean, you have to take these data with a grain of salt. And also, I still have to calculate some statistics to help us like tell if these distributions are different. And I mean, it's really just very preliminary at this point, yeah?
So, like, all kinds of jobs, like from janitor to dean?
This is just the deans.
Oh.
Yeah, so I have like many different job titles. Yeah, so here you can look at all the full professors, where you can see that there does seem to be a case where like there's a lot of female professors kind of like trailing towards the left side, right, and lots of male professors kind of like trailing towards the right side. So there does seem to be a little bit of a difference because the distributions aren't like completely overlapping, right? And also I have though still some problems with like identifying everybody who's in my set. So here are the associate professors. So I just have them by different job titles. And so here you can also see that like over the years, the distributions are kind of like starting to map each other more, right? So I think that's quite encouraging because it would also kind of like tell us that if there's any initiatives to kind of try to adjust salaries to be all more equal, then that would be going in the right direction. And assistant professors, you can kind of see the same trends, I believe. But still, I want to take everything with a grain of salt because these data are not like done at this point. Here are all the directors. And again, I find that like visually, if we look at it, it seems like there's still a bit of a difference, right? Like it's not like completely overlapping, but it may be going in that. And then also, for example, an example for research area specialists, you can see that these distributions actually are starting to kind of like converge into the same shapes. But let's look a little bit at departments and units because there may be differences by particular disciplines or depending if someone is faculty or staff. So what I found really interesting is, for example, in the history department, the faculty, the distributions are really overlapping. So there seems to be a lot of equality, which is, I think, again, is a very positive appearance. And the same seems to be on the law faculty. So, and you can actually see that in the beginning, it seemed to be more different, right? Like more than 10 years ago. But then slowly but surely, the distributions are starting to really map each other. And similar, for example, in emergency medicine, you're also seeing that the distributions are kind of like starting to really like trace each other. Similarly here, so there's a lot of these cases where I do see kind of these trends where they're starting to kind of come closer together, which would be great for HR, right? Because it's kind of like moving in the directions where we would try to get over this gender gap that we've seen in like earlier years. But then also there's, and again here, like it's the same, right? Like we used to have like a lot of men who were making more, but now slowly the women are catching up and like moving in that direction. So these are kind of like those graphs where we always kind of see the same. And this is, for example, computer science and engineering. I thought I'd share that because it's probably interesting to you guys. Where it seems to be kind of similar and actually also quite a few women at the end who are also having higher salaries. Yeah?
What's accounting for the outliers that don't continue? So is that just like...
I would think that this is probably like either like a full professor or maybe a chair. Yeah. And I don't know why they left. I would have to look into like...
If they left or if it was just like an initial hiring package or something that accounted for that.
Yeah, you sometimes see that chairs. Once I saw that a chair was like going to a dean's office for a year. So for 2 years they had like a really extraordinary salary and then it went back to normal. So you do see these changes sometimes. Yeah. That's also interesting, like in women's studies, either I'm not able to identify a man for the past 2 years, or they just left the department. But also in this case, actually, the men were making less than the women. So maybe that's why they left. And then we have also a lot of departments where actually there is still a gender gap, or there seems to be what I found is a blue wave that would not be so desirable. Because we are seeing how men are kind of like moving outward and women are not really following behind. So there's a lot of these examples as well that I want to share with you. For example, in a library or in aerospace engineering, where there's a lot, like quite a few men who are still making a lot of salaries, whereas women are like at a considerably lower rate. What I found interesting is the botanical gardens. They're actually starting to move farther away from each other. So they used to be the same, and now suddenly the men are kind of taken off, and the women are staying behind. Dermatology, health management and policy, kind of the same trend. The benefits office. And also no missing gender info, so there is not much that we can still do to correct for this, other than a policy change, I guess. The ISAR Director's Office and the Institute for Social Research. The Dean's Office in the Literature, Science and the Arts College. That's also staff, or a mathematics faculty. There seems to be like, it's less severe than in other departments, I guess. or physics, kind of like the same trend. Ross School of Business, there also seems to be a case where now some men are starting to make more money and the women kind of still have to follow suit. School of Information, which is like a big data science school, also seems to have this trend, and I saw a similar trend with staff. School of Nursing, which I found really interesting because you would think that a lot of women work in this area. And so just to give you some ideas, if you have a department you want to look at, come to me. I really have like most of them here if there is sufficient men and women to compare. I could show you. And what I want to do moving forward is I want to improve my data, obviously. I want to get all the information on all the individuals who I wasn't still yet able to classify as man or woman. And also I have to keep working on my faculty and staff distinction to really figure out which jobs, apart from professors and some instructors, are also counted as faculty by human resources. And I want to do some statistical comparisons of the distributions and actually maybe like make a rank from like worst to best and stuff like that to kind of like look better into my data. And I was interested also in maybe comparing job titles more by school than just by departments. I was also interested in if there's a difference in the salary increases, like percentage by every year between men and women, and also perhaps account for total numbers at the institution, because I can actually give everyone a unique identifier and then follow them through the university, and so account for how long they've been working at U of M. And perhaps also explore how they're moving through U of M. Maybe it's a good strategy to just keep applying to different units and that way kind of like increase your income. And maybe there's a way to deal with dual appointments, or someone suggested to look at ethnicity. So if you have any ideas for me, come talk to me. I'd be excited to talk to you. And yeah, thank you so much.
Any quick questions?
Sure. Yeah, please. Ben. Yeah.
I'm just wondering, I think you mentioned that you know the author or the owner of the data set.
No. I think how it works, I believe how I understand it works is that because the university does publish these data sets, and after scraping, someone actually told me that I could have downloaded the spreadsheets from the library website, which I wasn't aware, but I'll use that to kind of like figure out how well my scraping job did in comparison. Someone just takes these data and feeds them into this database and makes it available to everyone. But they do say in the frequently asked questions that they are not affiliated with the university.
Don't worry, Ben, you'll stay anonymous.
Did that answer your question?
Yeah, I was just wondering why were you scraping, doing screen scraping because you want them to learn how to do that, or?
It kind of was both, yeah.
Go to the database?
It was both. Like on the one hand, I wanted to just like apply my toolkit and kind of expand. On the other hand, I was really interested in the topic, and that seemed like a topic that I would keep working on out of interest. Yeah. Yeah?
Does gender ratio explain why there's large gaps in other places?
That's a really good question, because in general, actually, at the university, you see more women working there than men. So it's more like a 40 to 60% ratio. And there's many more women working in staff positions and more men actually working in faculty positions. So I do want to control for that in the future, too. Yeah.
All right, let's give Jule a round of applause. Great, so our final speaker is Ryan Feather. His talk will be about Beauty and the Beast, lessons from scaling AI at a startup.
Hi, thanks for the introduction. So this isn't going to be a very data-y talk, but the lessons are ones that, while working in data science and software engineering, I found to be somewhat hard-fought and save a lot of time once you learn them. So if this is kind of relevant to where you're working, hopefully it'll be an interesting talk for you. So what I'm going to tell you about is how we've scaled our AI in our startup. And a little context. What is that startup? First Fuel Software. We're based in Lexington, Massachusetts. And the problem that we're basically working on is how do you take the brain of someone who might go into a building and try to understand their energy usage and come up with recommendations about how to modify, how to reduce that usage. And we want to put that into an algorithm so that we can then take those sorts of recommendations and apply them to millions of buildings for our utility customers. And so I manage data science and analytics engineering, and I'll get into why that's a kind of a two-part group as part of this talk. What is the problem I'm talking about here specifically, right? So you have some very interesting hard math, right? Some machine learning or some statistics, some AI. And you want to take that and put it into your product. It's like your core IP, right? That's, you want to make it scalable. You want to make it robust. How do you do that? And I have a couple of insights, maybe some recommendations, some thoughts about like how you can actually manage that. So first, when you think about like any software problem or any structural problem, you want to think about the human side of it first. And a key question for me, whenever I think about this, like how am I going to build a group that does this, is, okay, well, how many really good software engineers do you know? And if you're working in software, then hopefully you know quite a few, right? And then if you think about how many really good data scientists do you know? Well, if you're working in data science or machine learning, that sort of research, hopefully you know quite a few of those too. But then how many unicorns do you know, right? How many people that are truly excellent at doing both the research and know all the machine learning and statistics, whatever is relevant to your problem, and are really good at software and really interested in architecture and unit tests and all that good stuff? And probably not a huge number, right? They're very hard to come by. But you can find some people that are really interested in machine learning, data science, know the lingo, the basic terminology, can be conversant, but maybe have some software experience and can do things like write a good API spec and think about what process looks like and talk to your software engineers. So what I actually think is a good mix is if you get maybe one of these people, I call them a glue person. For us, it's every 3 data scientists. For you, your mileage may vary. And they can actually shepherd your data science, your hard algorithms into the product. And I'll talk about a little bit how you can use your tools to help them do that too, as my second point. So when I think about tooling, I could go on. We've thought about this a lot. But one kind of major point is just how do you structure your project? How do you set things up so that people who are good at data science can work on data science and your software engineers can do really good software engineering work? And this probably isn't too controversial to say, hey, you should have probably a repository for your main product, and that can be where your core engineering team does most of their work. It's the back end and front end. Maybe it'll be Ruby or Java or whatever you like to work in. It's also probably not too big of a stretch to say that maybe your data science, your analytics can be in their own repository, right? And they're probably going to want to work in R or Python, which I've found works really well for this purpose. But this is where it might get a little scary to some folks, and that I say actually do your data science, your research in the same repository that you're going to put into production. And this actually works okay if you take advantage of your tooling and you have your kind of glue person managing that flow. So to give an example, if you're working on a Git branch and trying some new R&D idea, something that's completely new, and you want to see if it works, that's fine. You're on a Git branch. You can do whatever you want. You can modify whatever code. And once you've proven out your idea, if you have someone who's kind of on your team managing the flow, then you can do all the good things like code review and unit testing, etc. But you won't have to worry about messing up your production stack if you have nice things like that in place, right? So that's where your glue person really comes in handy. The reason I think this is actually a good flow, and I've worked in other flows before, is that if you think about the alternatives, well, you could try taking, your algorithm and translating it from whatever the researcher did their R&D into something you're more comfortable with for deployment, like C or C++ or Java, or whatever the case might be. That's going to be really difficult for a number of reasons. It's going to take a lot of time, and maybe there are some scenarios where this is the right choice. But if you think about, well, you have to do a full translation of that code. The software engineers have to understand that code really well, or have to understand the concepts really well to implement it. Your data scientists are now no longer going to have as much insight into the final product. They're not going to necessarily understand the Java or the C or the C++ as well. And it's going to be in some new format with lots of nice software engineering practices. So that's actually not a really effective approach in my opinion. The other approach I've seen done is you take the code, maybe still in its native language, but you go and plunk it in some production repository, hands-off. Data scientists can't even touch it anymore. Again, now your data scientists are no longer able to see what's going on in the final product. If you want to iterate quickly and make changes, then they may not even know what the current state of what you've deployed is. So again, maybe not the most effective, especially if you're like us, a startup who's exploring the solution space and trying to improve. So that's basically my two main recommendations. Get a glue person on your team who knows a little bit of both worlds, and then use them to shepherd your data science algorithms into your product, and do it in the same repository. It'll be fine. Thanks.
Time for a few questions. Alex? Can you repeat the question?
So the question is, how easy is it to find the glue person? And it's not extremely easy, not as easy as finding a software person. But I would say we've hired a lot of data scientists over the years, and we've hired 2 glue people. I was the first one at my company, and then we hired another one. And it's doable. It's about the same frequency that you'd find a good data scientist with, I think. But the key is really write your job spec well, know what you're looking for. Don't expect someone that's going to come in and come up with your new deep learning algorithm and do good software. You just need someone who has enough of a math background, and during your interview you know that your data scientist can talk to them. Does that answer your question? Yeah.
How did you become a glue person?
Interesting path. Didn't know what I wanted to do when I grew up, so I just did computer science, did some software engineering for a couple of years, decided I wanted to do something more interesting, so I did a master's in computer vision. And I actually ended up working in software again, but this time on implementing software algorithms, much in that kind of translation type mode of operation. And then I found then I found First Fuel Software, and they were really looking for someone to kind of fill that niche. And luckily, they hired me.
Any other questions? So with that, I'd like to thank all 3 of our speakers again, both Ryan, Jule, and Dana. Let's give them another round of applause.